All right, assuming all good to go. So, look, well, thank you everybody for tuning up. So, this is just, we've got the final version of the report just a little over 2 hours ago. And as Charles will explain the background to commissioning it, but you can expect in the early days of after the Moa Point sewage plant failed, a lot of effort goes into what is needed to get it functioning to the best extent it can. What do we need to repair it? This was one of the reports that was commissioned that was looking at flows through the plant, basically to ensure that as much as possible things went through the long outfall. If you've had a chance to look at the report or the executive summary, you'll see that in the course of that investigation it showed that there may be an issue about the way the water flows through, particularly where there's a sudden increase of fluid flowing through it, and because of the gradients at which the flows go, and suggesting that something for further investigation is whether air being captured somewhere in the network of pipes that flow through to the long outfall may have caused backup or backward pressure that caused the flooding. So that's essentially what the report is about. It is tentative, so there is further investigation. There are other reports commissioned focusing more distinctly on the cause, but this report is subject to further confirmatory examination. It's going off to London for further modelling because of the sophistication of the computer modelling they can do there. So while this helps point to an issue to be investigated, it can't be regarded as conclusive. So I'm going to throw to Charles Baker is the Chief Operating Officer for Wellington Water, for those of you who aren't acquainted with him. And we have a couple of diagrams that Charles will point to, but obviously these diagrams are available digitally for you once we're done. But Charles.
The report was commissioned off my immediate priorities that I gave the team at the scene. Those were to ensure that no odour affects the community, recover the plant safely, and get an understanding of what is happening with the long outfall and how to prevent further discharge to the short outfall. The report was commissioned within 48 hours of the incident and provides a really, really fundamental and important information about what was going on the night. It is just one part of that jigsaw puzzle. There are a whole lot of other contextual things that were happening in the plant. The plant was under maintenance. It was at night. We need to fully understand all of those things before we can conclusively say definitively what the cause is. But it is clearly evident in the report that this was a factor.
Can you really explain in real layman's terms how, basically it's a bubble, right? A whole lot of bubbles becoming one big bubble, how they end up?
What we can see here is that as it's actually gravity that pushes the water out into the long outfall. As it goes down, this is going to be awkward, isn't it? When it's going to jump from one to the other.
Can we control those?
Yeah, if it's possible. I can probably just talk to it. As that water flows through, air has to be allowed into the pipe to make sure that the pipe can breathe easily. When the water flow is rapid, what can happen is turbulence. The report is indicating turbulence could occur here, which is grabbing air and trapping it, and then that acts as a form of block. And the result of that turbulence there is it reduces the amount of flow down the long outfall, and that forces water back up the pipe. If the flow is more than can get past that point, it's got to go somewhere. And so what the report is indicating is that some air entrapment and turbulence is occurring here. You may remember that at one point a few weeks ago, we increased the length of this breathing vent by 7 metres. That was part of our initial attempts to ensure that air can flow more cleanly into that area.
So is it fair to say that that's a design flaw?
What we can say is that the plant was designed to put 4,000 litres per second through the bypass. We weren't getting anywhere near that at the time that the event occurred, but it would be rash of me to say that this conclusively indicates a design flaw until we've got all of those other circumstances crossed off. It's just as important in incidents like this to cross off what didn't happen to give confidence to what did happen. So we've got a really good indication now. We're on firm ground to keep looking and investigating and progressing our repair, but it is really important in these cases to give time to rule out any other causes or factors which could be influencing the night.
Was the bypass being used because of the UV work that was going on? So like, did one thing lead to another?
The plant is 30 years old and is due its deeper maintenance, and part of that is there was the UV project. Part of the UV project requires us to take a part of the channels offline. That effectively reduces the flow through the actual plant by about 50%. That means in wet weather events that we have to put more through the bypass because it's got to go somewhere out to it's got to get to the long outfall. That does mean that this is, in its 30 years history, this is a fairly unique combination of flows that would going through and around the plant, which maybe what the report is indicating could have caused the turbulent flow.
So it was a yes that the bypass was being used because of the work being done?
Yes, that's correct.
Thanks.
It was available. Most of the reason we were doing the UV work was it's summer, and it's important to remember that the normal flow to the plant is 810 litres per second. That was well within the capacity of the plant, even with the UV project going on. This occurred in a wet weather event when much more water heads towards the plant.
But this could have been foreseen, right? You knew you were doing the work. And, you know.
Yep. So I think it's really important to remember that everything that they knew about the plant and the plant was designed to do was indicated that up to 4,000 litres per second should be able to go down that bypass.
When you say, there's other factors involved here, but this is one piece of the puzzle, can you just kind of put that into, I guess, percentage, like for us to understand, like how much of the cause of all this entire incident is this part?
It's pretty clear if you read when you're reading the report, and especially if you've got an engineering background, this is pretty fundamental. This was what was happening, but how long it happened for, what other things were going on in the plant, could we have foreseen it? Those type of answers need to be come in. So there's cause and there's duration, and so it's really important that we bundle those things together in a really coherent picture and fully understand what was going on and how this event came to be.
Can you explain a bit more about why you haven't established cause yet? A lot of the public will be going, it's weeks on. Why haven't you got an answer yet? Can you explain it?
Yeah, I think it's been less than 2 months. We do need to remember what the team was faced with. It seems like a long time ago, but they were faced with a 3-storey building, the bottom of which was flooded with a combination of stormwater and wastewater. It's a really hostile environment. There's hydrogen sulfide. It wasn't safe. There's no power, no lighting. So I think everyone would understand that the first priority is to clear out the effluent, restore some lighting, make it safe to be in. It's only once it's safe that we could get people in there to start doing the investigations, assess the damage and things. So what I would give assurance is that, as I said before, within 48 hours we'd commission this report. Anything that we could get done and to bring more information to light was being done. But the fact is it was a very, very hostile environment inside the plant, and the team have worked incredibly hard to get it back to the point where it is safe to be in the building.
So I see in the report it said that modelling for the Moa Point plant was first created in 2023. So is that why you were able to get this report done so quickly, because you already had beginnings as such?
I'd have to be careful about which modelling, which part of the process we're talking about. What allowed us to do this quite quickly is that we could get access to the top of the outfall pipe and do a visual inspection with the camera. We also inspected with divers the diffusers which are out in the seabed, and that allowed us to kind of rule out other options that could have been causing this effect. And also that gave us good information to feed in. But at the end of the day, this modelling doesn't require a lot of access to the pipes. It just requires that basic information, the drawings, and then they can start doing that basic modelling. It is It is more basic, the modelling that we do in New Zealand, and that's why, although we are very confident this is a significant factor, we are commissioning the modelling, which is a deeper and more complex modelling in the UK, which is both useful to reaffirming that we're on the right track here, but also very useful because obviously every Wellingtonian would expect us to restore the plant but fix the underlying cause, and that modelling will be very useful to help us determine what the right engineering solution is.
Charles, you said that Wellington Water should address the potential risk of blockage or debris in the outfall. I assume that's along our outfall. Have you done that yet?
At this stage, no changes have been made to the long outfall, and so I'm not quite sure what you're referring to there.
Also in the executive summary, Wellington Water should address the potential risk of blockage or debris in the outfall section of the pipe.
Yes, so that's at the moment the way the outfall pipe flows out of the, as it exits the plant and heads towards the outfall, there is an open, that is not screened. You have to balance there, it's a good piece of advice, you have to balance screening things carries risk as well. So that'll be something that will be looked at in the engineering solutions.
Have you got the air out of the pipe yet? Is it still, that blockage still there?
The air exists in a moment. As the flow drops away, obviously pipes can breathe again, flow drops away. So it's not a permanent air block. It's just caused when certain dynamics of the water is moving in a certain way. As soon as that changes, it disappears, but it can come back.
When did you first sort of learn or suspect that the air may have been the cause?
For the engineers on the scene, it was clearly evident there was a limited number of options that could have resulted in this. That's why you would have seen a three-pronged approach from us. One was the immediate commissioning of the hydraulic report. This report, we also visually inspected the top of the outfall, and we sent divers to the diffusers, which is the bottom. So it was pretty evident it must be some of these things, and what we were doing is systematically ruling them out. As we got more information from the visual inspection and the divers, it became more and more apparent that it was highly likely that something was happening hydraulically in the pipes, and this report has arrived and confirms what our engineers suspected may have been occurring.
When was that? Or when did you suspect that?
I think it's evident that we commissioned it within 48 hours of the report. That was based on our engineering knowledge that if this is occurring, there must only certain things can cause this. So we ruled out systematically the blockages, a physical blockage, a collapse of the pipe somewhere, or a problem with the diffusers, and at the same time we commissioned the hydraulic report because what we knew, if those things came back clear, it must be something hydraulic happening in the pipes. And so it's a good evidence of the quality of our engineers and their knowledge of the plant that they could commission this report so quickly.
So you've known that this could have been an issue for weeks now?
We've known that we've made it very clear for weeks that this report is being done. I think that's a clear indication that we had a feeling that this could be a significant factor, and we've consistently told everyone that this report is coming.
I think, Charles, I heard you correctly too. You said it's one of a number of possibilities that could have explained what happened. And the nature of these things is it's quite good to get some evidential information rather than just speculation.
Yep.
The first draft that you had on the 27th of February, according to this, did that identify this as a possible cause?
Yes, the draft was by and large pretty similar to what was final. But what we need to understand is that for anyone that we commission a report like this for, they want access to our engineers. Our engineers know the plant the best, and so there's a prudent amount of passing a draft back for feedback because the people that we do get to do the reports know that we have deep specialisation as well, and that's the path to the final. I think it's really important to realise that the final came in only hours ago. Our engineers probably haven't seen the final and gone over it. That's the type of transparency that I know Wellington City Council expects of Wellington Water, and that's what we deliver.
Has Wellington Water been warned, or was it aware of this potential air issue before the failure?
There's no indication. As I said, the design of the plant was to allow up to 4,000 litres per second through the bypass, we weren't getting anywhere near that point when this hydraulic issue occurred. So there was no indication that we're aware of that this could have been a possibility.
The reports said that the plant operator had seen some air pockets burping since the Moa Point incident. So do you know if this was seen before the disaster, and could the plant back up the same way if this has happened since?
I think the second part there, that nothing materially has changed in the pipes. So the situation does exist that if we don't carefully manage the flows through the plant, that that it could result in flooding. What we can tell you is that that won't happen because we are now aware of the problem. But that's why we always go back to saying that in a large wet weather event, when the flows get back up to what they were on the night, there still remains the risk that we will have to discharge through the short outfall, because until we make these changes and repair this, which could take some time, that risk remains. But it's been carefully managed.
We don't know if there was any air pocket issues before the event.
When you say before the event, you mean?
As in whether this has been a problem for some time.
That goes back to what I was saying before, is the plant has operated for 30 years, but the flows paths were different because we weren't conducting the deep maintenance. The plant has become due for its deep maintenance, and so we were utilising the options that the design had, which was to put more through the bypass, allow us more space in the plant to do the repairs. That is the first time in 30 years that we've had to configure the plant to do that, and everything indicates to us that it was designed to be able to do that. So in the past 30 years, it's probably quite self-evident that it hasn't occurred, but it's more to do with the fact that we've had to configure the plant to do the maintenance.
Can we just go back to the night that all of this happened? Most Wellingtonians, and I'm sure many New Zealanders, haven't stood inside a wastewater treatment plant before. Can you just talk us through? I don't know if you were there on the night, but what would it have been like there on the night? How much water was there? What were workers faced with?
There's a few things there to understand. Is that, like all plants throughout New Zealand, the plant isn't staffed overnight. That's not a normal consideration. The plant is monitored remotely by people on duty, so it would be wrong to give an impression that there were physically people on the site in the room at the time. What we would expect in situations like this is a series of alarms and responses, but again, that is really important. That's the type of other parts of the jigsaw puzzle that we need to fully understand, and that's the role of the next report, which again we'll be transparent with, but it's really important to understand everything that was happening on that night, and everything that happened before. So we talked about the UV projects and things. We need to make sure that we all understand everything that goes around what we know is a significant factor that we've determined.
Would there have been any different outcome if there were people there?
That's speculative because there wouldn't be.
Was it adequately monitored though? Because wasn't FENS, they were the first to be made aware of it from an alarm? Was it being monitored properly?
Again, it's really important that we, today the report is about the hydraulic issue. What you're really asking now is asking me to speculate on the next report. As soon as we get that report and it's ready, we'll be transparent. But I'm not going to be drawn out into speculation about what people did or didn't do, or what should or shouldn't have been.
Just a technical thing: is a human needed on site to switch it to the short outfall? Sorry, is that like on site thing need to be done, or can that be done remotely?
It can be done remotely, but once the power is lost to the entire building and the control system's gone, it has to be done on the scene.
Okay, so if you had staff there, they could have switched over to the short outfall, because presumably the power's lost because of all the back flooding, right?
Well, I would say it the other way around. We needed a staff member to switch it into the short outfall on the night.
Did?
That was what occurred.
But where is remotely monitored from, New Zealand? Or?
Yes, yeah. There's a series of duty people that Veolia has on duty, and there's an escalation system. That, again, though, that is all going to be covered in the next report. What we're doing now is bringing what we know, and we know this.
And in the report, it mentions it talks about the quality
Mhm.
Can you talk to that a little bit?
Yeah, it's kind of well understood that wastewater is a fairly corrosive substance. All plants and pipes are subject to wear, both by the movement of the water and of the nature of the fluid that they're moving. It's not surprising at this point, given it's 30 years old, that there is some corrosion. But how much of a factor that was in the turbulence, that's the type of thing that the deeper modelling that we can do from the UK will tell us.
How much is that deeper modelling going to cost?
It's not cheap. An estimation would be in the hundreds of thousands of dollars, but it is very, very important in the scheme of the enormity of what happens when things go wrong. I think it would be very reasonable for Wellingtonians to want us to have the best possible data for when we reassemble the plant to give every assurance that this couldn't happen again. And that modelling is a key fundamental piece to make sure that engineers can make good decisions around their design solution.
Charles, sorry to go back to this, but have you always not had people rostered on site overnight, or is that a development that's come in recent years?
For a very long time. I'd have to. I'm not even. I'm not aware of what was in place 30 years ago, but I'm not even sure that I couldn't say for certain that it was even staffed 30 years ago overnight. So, yes, for a very long time. It's standard practice.
How much does this report cost?
I don't have that figure at hand. So I don't know exactly, but I can find that out for you.
In terms of the reports, are you able to walk us through what reports are coming and sort of the timeline of what they are and when they're going to be delivered?
There is a schedule, I think. There.
Yeah.
You haven't already got it?
Yeah, if I can. Yep, so if we just run down them, there's the hydraulic assessment, which is the report we're talking about today. There's the wider investigation into cause. We're looking there that we need to share it. What we're aiming there is to make sure that investigation cause is available to the Crown Review. So that gives you a good indication that we need to provide it before the Crown Review finishes its work. The damage assessment, stage 1 and the visuals are complete, and stage 2 is underway, and that's what's going to inform our repair options. Obviously, what we're really focused on now is sorting out everything that needs to be done, making sure that any critical spares or equipment that we need to order is ordered quickly, and because our focus remains to return the plant to operations as quickly and safely as possible to ensure that we minimise the impact on the environment.
So off the back of this report, what has it told Wellington Water in terms of what next steps need to be taken?
What it does is it gives us a lot of confidence. It gives us a lot of confidence that when we're repairing things which are in the plant and putting things back, that they weren't the primary factor. And it means that we can now press ahead and figure out what the design solution needs to be for this. It would be, if we didn't have this confidence, we would become hesitant about restoring the plant internally in case some of those were larger factors in the night.
We'd previously heard from Pat Doherty in that RNZ interview that there were potentially some early warning signs missed in the months leading up to the failure with some overflows. Do you now believe that those incidents were the same issue of the air bubbles?
When you have an incident of this magnitude, it's inevitable that as you go through with a fine-tooth comb, that you start piecing together indicative things. As we look at this model and we understand at times this symptom must have been occurring. Whether it was enough at the level to actually cause this flooding or not, it all depends. We need to remember that day to day, the operation, the plant only receives 810 litres per second. That wouldn't cause this effect at all. So 99 times out of 100 days, even in this configuration, this symptom wouldn't be caused. It's only caused by a unique combination when the configuration of the plant and large rain events. That's why, as I go back to, we keep moderating expectations, is that this effect could still occur. That's why to prevent it occurring at the moment in really large wet weather events, we haven't had one yet, and because our team have been really, really careful monitoring the plant and doing everything it can to optimise the outfall. we may need to use the short outfall, because until we fundamentally fix this problem, there is a risk to the plant, and we can't have the plant flood again.
Is there any indication as to how much it's going to cost to fix
The pipe?
Yeah.
No, not at this stage.
But did this effect happen at least extreme levels before the main failure?
No, sorry, I don't. You just have to
I'm just gonna
reply. You
say-
just have to. Do you have to ask me again?
But I think Charles talked about the set of circumstances that were in play on the night of the 3rd of February in the morning
Sorry,
of the 4th.
can we just get you in front of the
Sorry.
microphones?
Charles explained the set of circumstances that prevailed on the night of the 3rd of February and into the 4th that hadn't existed before. So I think your question presupposes that those circumstances had happened before, when the facts are that they hadn't.
So that never happened before, even at a small level.
I wouldn't want to say that, but you have to be very careful to presuppose that just because you can go back like that, that was predictable. I think it's really important to realise that everything that the plant was designed to take up to 4,000 litres. We weren't putting anywhere near 4,000 litres around the bypass. So inevitably, as we go back, I'm sure there will be some indications of higher levels of things that were. We can now look back and see that was the beginning of that symptom occurring. That's really, really important that we do find those things. That's why the next report is so important, because it's only when we fully understand all of that we can ensure that we put the plant back in a safe way that operates for another 30 years without this event occurring.
Do you have staff on overnight now at the plant to switch it to a short outfall if needed?
Yes.
We've been using the term air bubbles here. Is it as simple as that? You know, how would you explain it to the public?
Air bubbles is about the simplest as we can get away with. What it is my next explanation will be more complex. So what happens is it's stop me if you want me to repeat it again. As we go down, the flows. Sorry, we'll start with the water itself. The effluent itself has air in it. It's going through, captured from all across the city. It's coming. It's got air bubbles trapped in it already. As it comes down the outfall at certain speeds, it hits a dynamic, and what it's doing is it's starting to cause this what they've illustrated here is a bit of a wave, kind of foam, and that's sucking air down that pipe, capturing more air. It's called air entrapment, and that creates a kind of a foamy dynamic, which it's hard for water to get past. It sounds really strange that more air in a pipe could make it harder. You do want air like this at the top of the pipe. That helps. But when it's all mixed in, it acts as kind of as a foamy block. Probably the best analogy one of the engineers made is sometimes you pull the plug out of your sink and it doesn't go down as fast as you think because it starts going glug, 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 glug. It's that type of effect. A certain amount of air is good in a steady state. When it gets all mixed up together, the water and the fluid starts behaving differently. And we've got to remember that this is just not water trickling from a hose. This is thousands of litres per second under huge kind of speed. And so the normal dynamics that you might be familiar with water and stuff don't necessarily completely apply, and it starts behaving differently.
And so
That probably did not help.
So there was a good example, the sink one helped.
Yeah, well, maybe the sink helped. Like, that's good.
Do we need one of those things that you push on the sink like to help?
The incinerator.
Yeah, that one. Yeah.
We wouldn't support incinerators because incinerators bring more biomass into the.
But in terms of, you know, your pipe is engineered to deal with these sorts of situations. Do you think there was adequate engineering to typically deal with air bubble situations?
Again, we have to be really, really careful. It's the plant is 30 years old. Different technology and things and different abilities. We have different ways of modelling things now that were just unknown in the 90s. So all I can say is that the design at the time allowed for at least the amount of water that we're putting down it. So there's something fundamental there that needs to be addressed, and that is what we're going to do.
Just back to the point on staff now being there. When was that implemented?
From the incident.
Right. And why do you think that's important to have them there now?
Because at the end of the day, we need to protect the plant, and if flows ever come up to a point where there's any risk of this occurring, and the plant, then we need to switch to the short outfall.
They're confirmed too that the control systems that were there up to the point of the flood aren't there.
Yeah, that's a very good point the Mayor makes. The control system that was in place is non-operative, so it is a very manual operation at the moment.
In hindsight, if you'd had someone there, the electric's gone out, that you would have known and switched to short outfall, right? So in hindsight, having a staff like night would have stopped this.
I'm not going to really speculate. You could speculate a whole lot of alternative solutions that would have prevented this occurring, and the benefit of hindsight. All I'll just reiterate is industry practice across the Western world that plants like this aren't staffed overnight.
Is there any other important context from this report that Wellingtonians should know or that we haven't asked you yet?
No, I think I think the questions have been exhaustive and accurate. I just would reiterate that it is really that we are being transparent. Our own engineers have only had this report for a matter of hours, and so what we would want to give a really good assurance to the Wellingtonians is we're honing in on the fundamental things that happened on that night, and they can therefore be confident that the money that we are spending to remediate the plant is done in a way that's structured and will lead to the long-term prevention of this occurring and making the plant operational for another 30 years.
Charles, the Valley and Horidoa have both been calling for kind of reassurance that something similar won't happen to the other wastewater plants in the region. Can they take this report and take any sort of confidence that they won't see something similar happen in our other wastewater plants?
Moa Point is a unique plant, in fact, that it's had to be placed in a unique position on top of a hill. So therefore, some of these dynamics just don't exist normally in wastewater treatment plants. Wastewater treatment plants usually spread over acres. But what they've done, I think Wellington faces this dilemma quite often, is we have to deal with the topography. So this plant is 3 stories high, and all those things are they're normally spread out over a wide range of area, housing the same thing. So there will be lessons and things to learn. They may not be directly because this type of scenario can happen, but I think that's probably more for the next report, which is the over the surrounding factors, which, while may not be so important to the cause, probably are the lessons that we need to share with the rest of New Zealand and the rest of the industry.
And there was just one other thing in the report that I'd like to ask you about the slope of that pipe. Were there any concerns raised around the angle of the pipe?
Are you talking about the bypass on this one here?
No, the one, that one. Well, because you mentioned the design of the plant, I think there might have been a page in there about the actual slope of the pipe being an issue.
Those photos in the report were, you can point out where they were because they're one of these. I think they were up there.
So you're talking about the actual photographs that were in the report?
I think so.
Yeah, they're around this area here, which is where where it hits here, then comes down, and maybe this T junction around here.
But further down, there's no issue?
No, I think what is clear is the plant has operated with this volumes of water many times. So the outfall pipe, this here, has easily got the capability of passing the amount of flows that we saw on the night. What is different on that night is due to the deep maintenance and the 30-year maintenance that we're conducting, we've had to configure the flows to come at different rates. So that generates, that unique set in circumstances generates what wasn't predicted, this air entrapment or turbulence. And so normally the outfall pipe has plenty of capacity to get through all the normal rates of flow that we pass through.
So we'll just finish
That
on
answer?
just one issue. I'll just finish.
Yep.
Bit of an announcement, I suppose. Just so you're aware, you might be aware of the way Wellington City Council funds the work it requires Wellington Water to do. It provides a certain amount of capital funding each year. The amount provided for this current financial year has been underspent by about $15 million. As a consequence of that, and given the urgency of these repairs, we've been able to give consent to Wellington Water to draw down a chunk of that, between $8 and $9 million, to order the new kit that is needed, the control systems that are needed, so that order can be put in immediately, and those control systems can be reinstated as quickly as possible. So that should expedite the repair and reinstatement of the plant, subject to the further investigation and clarification of these issues, and whether there needs to be any design aspects addressed in the overall repair.
Just one more question for you. Is there any other assurances you'd like to give to Wellingtonians just off the back of this report?
Just for everybody to know, this is top priority for me and the council and for Wellington Water. This has been given the urgency that is required, and everything that we can do or that can be done is being done. We don't want raw sewage to keep on being pumped out into the Cook Strait any longer than is needed, but we want to make sure that the repair that we do, as Charles has said, is such that we minimise the chance of this incident ever happening again. Thank you all. They did the report.